Last episode, we talked about the ether. That's the medium that carries the field. Now, let's look at what the medium is actually doing. Because they've measured it, published it, and if you look at the numbers without forcing them into a model where they don't fit, it tells you something that they never taught us in school. Now, behind me, this is the IGRF. It's the International Geomagnetic Reference Field. It's NASA's model, NOAA's model. Every space agency in the world uses this data. And the first thing you notice is it's not symmetrical. It's deep red at the Arctic, 62,000 nanoteslas, lighter orange at the Antarctic, 43,000, and at the tropics, north and south, it drops to 28 to 30,000. That dip in the middle is the key, because what you're looking at is not one field. Watch what happens when you stop forcing this data into a bar magnet model and let the geometry show you what's actually there. Two toroidal loops, two complete systems. Field rising up out of the Arctic, arcing over the North Hemisphere, dropping straight down at the tropical boundary at the Tropic of Cancer. Then it goes under the Earth, through the Earth, it goes up, out, rising out of Antarctica, arcing over the Southern Hemisphere, dropping straight down at the Tropic of Capricorn, and then goes through the Earth, up back to the north, creating the figure 8 loop. The Arctic is the emitter. The field lines rise up out of the ground. That's the North Pole. The tropics are the receivers. That's where the field drops in. And right here where the two loops meet, where the south pole of one system and the south pole of another occupy the same latitude band, that's not a gap. In magnet physics, this boundary has a name. It's called a block wall. The interface between two counter-rotating field systems. High pressure seal between two different worlds. Two systems. One plane. What that boundary does and what it means, that's coming next. Last episode, we traced the circuit. Field up at the Arctic, down at the Tropic of Cancer, through the Earth, up at Antarctica, over the south, down at the Tropic of Capricorn, back through the Earth. One continuous loop at every meridian. Two complementary fields. One dual system. Now, let's look at what that geometry does to a compass. We have three needles, one at 45 degrees north, dipping down into the ground, tracking the northern field as it curves toward its receiver at the Tropic of Cancer. Now, if you take that same dip compass and bring it to 45 degrees south, it will be dipping down into the ground, tracking the southern field as it curves towards its receiver at the Tropic of Capricorn. And then we have another right in the tropical gap, the dielectric zone, flat, perfectly horizontal, not dipping in either direction. That line has an official name. Scientists call it the Euclidean line. It's in every geomagnetics textbook. It's measured, published, peer-reviewed, and what it tells you is that inside that block wall in the dielectric, between the two tropics, the field is not above the surface at all. It's underground, transitioning between the two complementary systems. That's why the needle sits flat. There's nothing above the surface to pull it. Now, if we run the numbers straight from the IGRF data, the northern field, 62,000 divided by 30,000, mirror ratio 2.07, above confinement threshold. The southern field, 43,000 divided by 28,000, mirror ratio 1.54, below threshold. Same circuit, different strengths. Male and female aren't identical. They're complementary. The system doesn't need them equal. It needs them imbalanced, asymmetric, seeking balance. Now, here's what this dual field geometry produces above the surface. Stand in the north and watch the sun. It arcs counterclockwise, rising and setting left to right. Cross the block wall into the south and watch the sun. It arcs clockwise, rising and setting right to left. Same day, same meridian, opposite directions. That's not perspective. That's a mirror reflection across a field boundary. And this is the behavior that you'll see every single day. I have some honest questions about what this magnetic field data actually means. What's not contested, the IGRF data shows the field is stronger in the north, 62,000 nanoteslas at the Arctic versus 43,000 at the Antarctic. That asymmetry is real, and it's a problem for that simple dipole model, even if it's a tilted dipole like they say, which is why the IGRF is on its 14th revision. A bar magnet has roughly equal poles. This field doesn't. What's also documented, compass needles dip towards the ground at 45 degrees north, tracking the field as it curves toward its receiver at the Tropic of Cancer. Manufacturers add a counterweight to the south end to keep the needle level enough to still spin so it doesn't hit the housing. That weight tells you which end the field is pulling. The opposite end. And the north end goes down, so they put the weight on the south end. This is confirmed just by where the weight sits. Now, where it gets interesting is southern hemisphere compasses are built differently. The weight is on the opposite end. But there's more. I researched into the KRNet archives, a gathering place for experimental aircraft builders. A pilot asked whether his northern compass will work in the southern hemisphere. The answer was direct. The needle points 180 degrees the wrong way. Their solution is to reverse the card, flip the labels. That's not an offset correction. That's a field inversion. Commercial compasses are also calibrated against other compasses. They're adjusted until the point of the expected direction based on the maps that they're using to align them with. That's why they can't independently verify the field geometry. They confirm each other based on an already established map of the magnetic field lines. That's circular methodology worth questioning. And special credit to researcher Lindsay Harris from Tomb of Illumination, whose work helped frame these questions for me. I will link his channel in the description. But what's certain, the IGRF data does not support a simple dipole, even if it's tilted. And what I'm still investigating, exactly how the southern field behaves with an uncompensated instrument. If you're in the southern hemisphere, I want to hear from you. What compasses do you have? What does it do? Let's collect real data. The weight knows something. The reverse card knows something. I'm still figuring out exactly what. But airplanes, it's all digital. They just sit there on autopilot. We have the field data, we have the acclinic line, we have the mirror ratios. Now, here's a part you can verify for yourself. No instruments, no physics degree, just look up. In the northern hemisphere, the sun rises from the east, arcs right. Sets west, arcs right again. Counterclockwise. In the southern hemisphere, the sun rises from the east, arcs left. Sets west, arcs left again. Clockwise. Same day, opposite directions. Every day of the year. That's not disputed. That's observable by anyone, anywhere. So think about what that means geometrically. If the sun moves right for a northern observer and left for a southern observer simultaneously, those are two opposite vectors. You must ask, how can one object have two opposite paths? The globe model says that's just perspective because you're oriented differently. But watch the vectors carefully. That's not perspective, that's a mirror. Now, the analemma, if you photograph the sun at the same time every day for a full year, in the northern hemisphere, the large loop is on the top, small loop on the bottom. In the southern hemisphere, it's vertically inverted. Seasons swap positions. That's documented from primary source photography. That's two observable phenomena, both mirroring across the same boundary. The same boundary the IGRF data identifies. The same boundary that has a name in geomagnetics, the acclinic line, sitting inside what magnet physics calls a block wall, the tropical gap, the equator. These aren't fringe claims, they're in the literature. What's not in the literature is a clean explanation for why the field producing all of this so dramatically is asymmetric. 62,000 nanoteslas north, 43,000 south. A dipole doesn't do that. That's my conclusion. That's their data. We're just reading it honestly. 4 episodes ago, we started with the IGRF, NASA and NOAA's own magnetic field data. We ran their numbers. We found a field that doesn't behave like a dipole. We watched the sky mirror itself across the tropical boundary every single day. We asked hard questions about the instruments used to measure it all. So, what does it actually mean? It means the model they taught you is incomplete. The IGRF is on its 14th version because a simple bar magnet model keeps failing to predict what their instruments actually measure. The quadrupole component in their own spherical harmonic data runs 2.7 times above what a pure dipole predicts. That's not my calculation. That's in their published data. They know the model doesn't fit. They keep patching it, saying it's an asymmetric dipole, but it means the asymmetry is real and unexplained. A field stronger in the north than the south by a significant margin, with a documented zero-dip boundary between the tropics that behaves exactly like a block wall between 2 magnetic domains. That's a specific, measurable, reproducible geometry. It points towards a structured dual-field system rather than a single rotating dipole. It means the questions are more important than the answers right now. And I'm not telling you what to think. I'm just showing you what the data shows and asking why the model doesn't match. It's not a conspiracy. That's how science is supposed to work. You're not a biological accident on an insignificant planet in the middle of nowhere. You're a conscious node inside a system precise enough that their own instruments require corrections, counterweights, and modifications depending on where you are on Earth. And it's not because the instruments are broken, but because the field geometry demands it. That's not raw data confirming the model. That's engineering workarounds hiding what the raw data actually shows. And that's why you have to make those adjustments when you travel. So at this point, these are just questions. Hopefully someday we'll have all the answers. But in the meantime, it's important that we continue to work and continue to learn. Knowledge is power. Seek and ye shall find, and the truth shall set you free.